Hello, this is Dr. Dave Maslach talking to you about reciprocity.com, the sharing economy proofreading platform that I'm trying to build. And in this particular video, I really wanted to talk about different threats to internal validity, specifically selection biases. So this is part of my Nerd Out Wednesday series where I go into things that I find interesting. So I'm a professor of innovation strategy and entrepreneurship. And I really wanted to get into all of these issues because they're so important, and they were very pertinent to me actually creating this particular platform. So I really wanted to get into what these issues are, and I wanted to help out as many people as I possibly can by creating these YouTube videos. Now, I'm by no means an expert in any sort of way on this kind of stuff. There's so many more people that are so smarter than me with this kind of stuff, but I thought I'd put this stuff out of things that I've learned along the way. So I wanted to be as helpful as I possibly can. So in this particular video, I really wanted to get into, what is, first of all, I'll just quickly define what internal validity is, then get into what a selection bias is and what it might look like, both with sort of surveys, in terms of experiments, and as well as in sort of empirical archival data, right? And then finally, sort of different things that you can maybe do to look at these effects, right? To see if it's problematic or not with what you're doing. So what is a selection? Well, what is internal validity? That's where you have some reason to believe other than the hypothesized effect that you have is leading to the results that you see. So if there's some sort of threat to internal validity, then the hypothesized results are likely caused from something else that you are not sort of accounting for in some sort of way. So a selection bias, this is where there is people or subjects or whoever you're looking for, the particular the object or subject of interest is selecting into the study in some sort of way, or selecting out of the study in some sort of way that it's affecting your results and leading you to believe one thing over another. So that's the basic story of it, is that there's some reason why the subjects are entering into your study and they're sort of contaminating or affecting your results. So this might be if you have a experiment and you put out a post, right? A sort of large experiment. You say, I'm doing an experiment on blah, and then people that are interested in blah respond to that. And then there's a whole host of other people that are, non-blah interested. They are not going into that study. And now that could affect the results that you have, because the ones that are not interested are somehow fundamentally different, and they're sort of more representative of the general population than the ones that did select into that population or select into that study. So maybe you're interested in high performance, for example. Now that's going to that's if you send out a experiment or a survey that says, I'm interested in people that are interested in high performance. Well, that's typically probably going to only be maybe athletes, maybe sort of top executives, for example. It might be only people that are very concerned about performance on a regular basis, and they're thinking about that. And then there's everybody else that doesn't give a hoot about performance, right? That they're not interested in performance. And so everybody else is probably more the general population, the regular people. They are going to answer the questions, or they're going to behave in a different way than what you thought they were, right? So one of them might be, maybe you're looking at the effects of testosterone on performance, right? So then you send out the survey that says, I'm interested in those that are interested in high performance. Then only the ones that are interested in high performance, probably it's going to be, again, executives, athletes, people that are like that. They're going to, in general, athletes, for example, they're probably going to have a little bit higher testosterone anyways. I'm not saying one way or the other with, in terms of the sexes, but they're there's a high likelihood that they're going to have a little bit higher of testosterone just simply from exercising all the time, right? So then you're more likely to see an effect between testosterone and performance by selecting on those, rather than just saying, in general, if you just open it up and you have a sort of a broader audience, then you might not see an effect. Or the opposite could be true, that you're only selecting on such a narrow set of people that it appears that there's no effect going on there, because those ones already have higher level of testosterone. And again, I'm just making this up, right? I'm not an expert in any sort of way, but you're selecting on the ones that have high testosterone, and then you look at the effect on performance and you see absolutely no result. Well, that's because you're looking at the ones that have very high testosterone. If you look at the ones that have low testosterone, you compare the two, well, you might see a very large effect, because the difference is very large with that independent variable that's changing, right? So you have to be very careful about that. The other thing in what I'm interested in, often I look at archival data, right? So then I look at how firms change over time, and the performance on firms, and how that changes all the time. Now, you might see some firms entering and exiting the data set at different times, and they are entering and exiting for different reasons, right? Some of them are startups, maybe some of them are not startups. Maybe they're going through mergers and acquisitions, all this kind of stuff that are entering. Well, that's going to have effect on your results, and you have to make sure that you have to rule that out as much as possible, right? So how do you rule this out as much as possible? Oh, one more other thing I forgot to mention. There could also be kind of what censoring, sort of censoring effects. You get like on left censoring or right censoring. This is when you start your data set, if you're looking at a large empirical data set, and you say, I'm only interested in all the firms that start after 1980. Well, all of those ones that were running and existing from 1980 on, or before that, and they're continuing to persist, well, then you're not looking at those effects before 1980, and that's going to bias your results in one way or the other. So there's different ways that you can look at this and control for this, and it just depends on your scenario, and you can look at them, and I'm just going to point you to the direction so you can look at them. The first one is just go through and compare the ones that were selected versus the ones that sort of select into the data set at different times to the ones that sort of are persistent throughout the data set. If there's a difference, then there might be something going on. It might also be the case that you're more interested in the ones that are persistent over time, because they're sort of unusual or different, or they're explaining your theory a little bit better, right? The other thing you could do is add dummy variables in any model that you have when you're doing a regression. That sometimes is helpful. So left and right censoring, you see dummy variables over once in a while in terms of controlling for this. You could also do a Heckman selection model to predict which ones are going to exit or have a higher likelihood of exiting or entering your data set, and predict those effects that happens. You could look at that. It's kind of a cool procedure. Same with the Tobit. A Tobit model is very similar in that you're looking at censoring effects over time. So maybe you only observe on the dependent variable performance that occurs. So there's no performance effects at all until maybe at some point there's a threshold that gets surpassed. So at maybe at 50 parts per million testosterone in the blood, that there's an effect that happens. Well, it's just because the test is only being, it only allows you to look at anything above 50 parts per million. Everything below, the test is just not doing a very good job of picking that up. So there's some sort of censoring effect there. And you can look at a Tobit model is going to account for that and try to look at the effects all over the entire distribution as much as you possibly can. You can also do some sort of, and both of these are kind of instrumental variable models anyways, but you can look at an instrumental variable regression model. There's all sorts of different ways to look at this. Probably the best way is to rule it out before you even start somehow, trying to figure that out. And that is maybe some sort of experiment that you are comparing the treatment and control in some sort of way that it rules out this selection bias and it's not necessarily all that important, and then justify why that is as much as you can in the paper, whatever you're writing, right? Justify as much as you possibly can whenever you're going through this, and be really, really rigorous with that justification. That's a really good way of doing it. And that's part of the reason why I'm doing reciprocity. Actually, it's a big reason why I'm doing reciprocity. So I recognize that there is a problem with how we are currently measuring performance and looking at organizations. And we could do, in the software industry, there's this really cool thing that's happening, and it's huge. And most software companies do this now, is A/B testing and do thousands of tests. And this is kind of experimentation where you can compare the treatment and control, right? The control to the treatment over time, and you can see what the effects are. So that's why I'm building this out. I think it's a really cool tool, so I can, or at least one reason, I want to be helpful as much as I possibly can, but then also have access to this tool to do these treatment control groups and do sort of little tiny experiments. So that's it. That's what I wanted to talk about, this threat to internal validity, selection bias. This threat to internal validity is really important. Selection bias is really incredibly important. First of all, it can affect your results in both a way that you expected and a way that you didn't expect. Selection biases they affect your results in both the experimental stuff or survey stuff, as well as when you're doing secondary data and looking at secondary data as well. Selection effects also can be sort of controlled for or ruled out in various techniques such as Tobit models and Heckman models, and as well as sort of the regression or the design that you have, experimental design that you have. You can rule out some of those effects as much as you possibly can, but at the end, I want to also point out the very last thing is that threats to internal validity, no matter what you do, every study is going to have it. So you're going to have to really demonstrate that there's not these threats to internal validity as much as you can, but studies are still going to have it. No matter how rigorous and robust you try to make things, there's still some sort of threat there. And selection is one of them, that they could still affect your results. But you have to demonstrate how selection is not affecting your results and the internal validity of your study. So that's it. Have a good day. If you like these videos, you can watch some more if you want. A bunch of them, particularly on Wednesdays if you're looking at that. And that's it. Have a good day and take care. And I'm looking forward to seeing you on the next video. Bye.